The curve with this equation then, here, is sketched below. The point O is at the origin, and the curve passes through A, minus 1, 0, and B, 1, 4. Given that y equals this equation, then find dy dx, find d2y by dx squared, find an equation of the tangent to the curve at the point A, verify that the point B, where x equals 1, is a minimum point of the curve. So I've summarised the question and paraphrased it here. So let's have a look at it then. Part A first of all, dy dx. Let's have a look at this then. The derivative function, the gradient function. Power rule, 5 comes down, x to the 1 less, which is 4, minus, the 2 comes down to be with the 3 to make 6, x to the 1 less, which is power 1. X goes to 1, and the constant goes to 0, doesn't it? So there's dy dx. Now d2y by dx squared then. Part 2. d2y by dx squared is equal to, power rule again, 4 comes down to be with the 5 to make 20, x to the 1 less, than 4, which is 3, minus, the x goes to 1, and there's 6 lots of, minus 6 lots of 1, is minus 6, and the constant goes to 0. So there's the second derivative. Find the tangent at A, minus 1, 4. So part B, at x equals minus 1 then. What does dy dx, the gradient, equal? Put minus 1 in here. Minus 1 to the 4, even power, so that's 1. 5 ones are 5. Minus 6 times minus 1 is plus 6, plus the 1 that's already there. So that's 11, 12. So there's the gradient. We know the point A, so we can now write the equation of the tangent. So y minus the y value, which is 0, is equal to the gradient, 12, times x minus the x value. Minus minus is plus 1. So that tells us then y is equal to 12x plus 12. So there's the equation of our tangent at A. Verify that B, the point B, is a minimum then. Okay, so dy dx equals 0. So this is part C now. So here, this equals 0, 5x to the 4. Verify that B is a minimum. Okay, we just need to verify, we don't need to show. So let's put it in then, at x equals, the B value was 1, wasn't it? Here. So when x is 1, dy dx is equal to, put 1 in here, 5 times 1 to the 4 is 5. Put 1 in here, minus 6 times 1 is minus 6, and then we've got a plus 1. So it is a turning point. And the second derivative, we need to show that's negative. At 1, so it's 20x cubed times 1 cubed minus 6. That's 20, minus 6 is 14. Positive, so a minimum, which is greater than 0. So a min at x equals 1. So it's a minimum here at x equals 1 then. Let's just verify the y value. What does y equal? Well, we've got our original equation. Here, 5x to the 4 minus 6x plus 1. 5x to the 4 minus 6x plus 1. So the x value is 1. Put it in. 5 minus 6 plus 1, which is 0. So I'm a bit worried about that because it said B1, 4. So verify B at x equals 1, wasn't it? Is a minimum. And oh, our original curve, sorry, was here. So let me just copy that. That's the y value, not the dy dx value. And that's the value we want. Edit, copy, edit, paste, and I'll just drag this down now and we'll put the values in for this. I mistakenly, without thinking, put it in for dy dx, I think. So this is what we need to worry about here. So we can get rid of this then and get the correct y value at b, which we know is going to be 4. Let's just verify that point. So that's equal to 1 to the 5 is 1, minus 3 times 1 squared is minus 3, plus 1, plus 5 at the end. So we've got 7 minus 3 equals 4, which is what we wanted to show. Y equals 4. So we've confirmed it's a minimum at b then, haven't we?